The quotient rule for derivatives is going to be our second, more advanced technique to find the derivative when you have a function over another function. So you have maybe a rational function of some kind, or you have some kind of function in the numerator and function in the denominator. There's a fun little saying that we can do with quotient rule. And it goes like this. It goes low, D high, minus high, D low, all over low squared. And you might want to pause the video and say that a few times to yourself. But what does that mean? Well, high is your numerator and low is your denominator. And so whenever we say D, we mean take the derivative. So you're going to do low, D high, minus high, D low, all over low squared. If you want this in maybe some other type of notation that's not quite as messy as this one, then its derivative is going to be low times D high, so times U prime, minus high U times D low, so low prime, all over low squared. Let's look at an example right here. So I have 5x squared over 4x plus 3. Now I could divide this out with long division. That's not really going to change the fact that I'm going to end up having a rational function. So you can do that, but it's not really going to get you anywhere, okay? So in order to take this derivative, I'm going to do low. D high would be 10x minus high. D low would be 4, all over low squared. Let's go ahead and simplify some of this. So I'm going to end up having 40x squared plus 30x minus 20x squared all over 4x plus 3 squared. And so I'm going to have 20x squared plus 30x all over 4x plus 3 squared. All right, let's look at an example with particle motion. The position of an object on a horizontal axis at any time t is given by this equation. What's the initial velocity? So meaning what is v of 0? Well, let's first find s prime. So that's going to be low. D high would be 1 minus high. D low would be 2t all over low squared. Now it might be easier, like in this case, to just go ahead and plug in 0 right now and say s prime of 0 would then be 1 times 1 minus 0 all over 1 squared, or 1. You could go through and algebraically simplify this if you wanted to and then plug in 0, but you're going to end up getting 1 over 1 squared anyway. All right, let's use the quotient rule to show why the derivative of tangent is secant squared. So remember, tangent is sine x over cosine x. So if I take the derivative of that, I would have low. Now let's do our circle. D high minus high would be sine. D low, derivative of cosine is negative sine, all over low squared. Negative and a negative here make this positive. I end up getting cosine squared plus sine squared in the top, all over cosine squared in the bottom. Now before you might say like, oh, those cosine squareds cancel, because that's very tempting to do. They do not. However, this numerator, sine squared plus cosine squared, is 1. And 1 over cosine squared is secant squared. Let's do a couple more. If I needed to find f prime, we would do low d high minus high d low all over low squared. This one I am going to do a little bit of some cleaning up. I'm going to factor out an e to the x in the numerator. And I'm going to write this as e to the 2x. I do end up having 1 e to the x cancel with 1 in the bottom. And so the most simplified version of that derivative would be 2x minus x squared over e to the x. All right, let's look at g prime. So I have low d high minus high d low all over low squared. The only thing I'm going to simplify here is just that x over x would give me 1. And then I'm going to go ahead and just leave this alone. There's nothing else I can do. Like these x's don't cancel, we just leave it. All right, let's look at C. This one's going to be so fun. We have all of the different types of functions in this, I feel like. Okay, h prime equals low. Now, when I take the derivative of the top, I have a product rule. So low, and then I need to take the derivative of x e to the x, which is a product. So derivative of the first times the second plus the first times the derivative of the second. So that's our low d high. Minus high d low. What's the derivative of sine? We have cosine, right? All over low squared. Let's clean it up just a smidge. So I have e to the x sine x plus x e to the x sine x minus x e to the x cosine x all over sine x squared. And it doesn't look like anything is going to simplify further from there.